My pleasure to welcome Zuyi Jacky Huang as our presenter today. He's an assistant professor in the Department of Chemical Engineering at Villanova University. A little bit of background on Jacky is that he received his Ph.D. at Texas A&M in 2010. He's now an assistant professor. He teaches process control. He just finished this semester and then also systems biology for graduate students. He's enthusiastic about applying innovative teaching methods in class to educate students with modeling and control skills. He and his colleagues at Villanova, they recently received the 2016 American Society of Engineering Education Joseph J. Martin Award, and he is the director of the Biological and Environmental Systems Engineering Lab, or BESEL. His research is focused on developing advanced modeling and systems analysis techniques to manipulate microbial biological systems for generating biofuels from wastewater and for combating biofilm-associated pathogens. We're especially fortunate to have him today for the inverted classroom approaches to educate undergraduate and high school students with MATLAB and process control and modeling, and he's going to be sharing some of his experience. There's also a paper that he recently published on this, and hopefully you'll be able to share some of that information with us throughout the presentation. So with that, I'll go ahead and turn it over to Jacky for his presentation. Thank you and welcome, Jacky.
Yeah, thanks, John, for the introduction and the invitation and to keep this webinar. I'm glad to share the teaching modules I developed in the last 2 years and to educate high school and college undergraduate students and with the MATLAB skills in process control and modeling. So here is the outline of my talk today. I mainly focus on 3 projects. So first, I will introduce a project done by a high school student in the summer of 2014 in my lab, and that student developed MATLAB Simulink model for microbial cell, and he also play around with the PID controller design. And actually, it's that project that motivated me to develop the flipped classroom teaching modules for the course I teach at Villanova, the chemical process control. So this is my second project I'm going to show you today, and I'm going to show you the modules, the 3 modules I developed in this course, and also give you some feedback of the student and in the flipped classroom teaching approach. And project 3 actually is an extension of project 1. So in project 1, the high school student came to my lab and got a training in person and did the research in my lab. In project 3, and the student did not meet me. They watched the teaching modules from the internet and actually from YouTube. And then we had a Skype meeting, so it's all web-based. But I will also show you some feedback from the student on this web-based teaching approach. Here some background about the project and to explain why I developed these teaching modules. So as you may know, right, the math performance of U.S. high school students are not ranked top 1 anymore. Actually, they were ranked top 35 in 2015. And according to another survey, and here, and 56 U.S. high school graduates in 2013, they were not ready for the college level math. So you may wonder, well, whether the situation is better for college students. Actually, it's not better. So here is some information compared to Japan and China. Right, in 2008, we had much less students and were awarded in the STEM field. Well, even some students pick the STEM field as their major. 38% of them fail to graduate in time. So as the teachers right, in the STEM field, actually in process control and modeling, I think we should figure out a way to attract more students to choose the STEM major. Also try to make the STEM research more funny and more cool to students. And so one idea come to my mind is maybe we could provide some tools that help students to build their confidence, or also make the modeling or mathematical operations more funny. And so one tool is the MATLAB Simulink. So for example, for this water tank, and we use this ODE equation to describe the liquid level in the tank, and then we could develop the model for this equation in Simulink just by linking those modules provided by Simulink together. And this just like the kid playing Lego. So I assume that the students should be interested in Simulink. So in addition to providing a good tools, we also need to provide some interesting projects that related to the students' daily life. And so my group at Villanova is developing systems biology approach to engineer bacteria to produce bioenergy. Also, we also identify the proteins target and for drug development and to eliminate bad bacteria like pathogens. And I show my research project to the students, and he's right in the summer of 2014, and the student was more interested in microbial fuel cell. And now I want to show you a brief introduction of microbial fuel cell, if you are not familiar with microbial fuel cell. So similar to traditional bacteria, we have anode and cathode. So differently, we grow bacteria on the surface of the anode, and these bacteria are specific bacteria that actually called electrogenic bacteria, and can produce electron from organic compounds, right? For example, organic compounds from wastewater, and this is a little cartoon show you the mechanism of microbial fuel cell, and we can see that the organic compounds is converted to carbon dioxide and electron and proton, and then electron translocates through the external electrical circuits to the cathode, and then react with proton and hydrogens to produce water. And this reaction in the anode and cathode, and this is what the microbial fuel cell look like. And you can see that microbial fuel cell provide a sustainable approach to treat wastewater, and at the same time produce bioenergy. And the student, he was very interested in this project, right? And then after that, I introduced the ODE model of the microbial fuel cell to students. Well, due to the space constraint, I don't show you the all equation and of the model. And here just a brief introduction of the model. So this ODE model describes the concentration of the substrate in the reactor, and also the population of the exoelectrogenic bacteria, by which can produce electron from wastewater. And another bacteria here is methanogenic bacteria, and they can produce electron. And also we had the equation to describe the proteins inside the cells that carry the electron from the cell to the anode surface, right? Because with the atom. And also we had the equation to quantify the electrical current signal. Now, actually some coefficients, for example, this growth rate mu A and growth rate mu M, they are the function of the substrate, right? We had 9 more equations for all these coefficients, right? So I don't show them here. But anyway, this model is pretty complicated, and it has 25 parameters. So I want to test the student, all right? If the student can, the high school student can handle this complicated model, right? And in Simulink, so this means that it's doable to introduce Simulink to the high school student, and then to let them to do some research, and then maybe and then attract more students to stay in the STEM field, especially in modeling field. And well, when I introduce the ODE model, I will explain the physical meaning of each term so that the student understood the model. So after that, the student worked 2 days and in 1 week and in my lab, and he developed the ODE model for different components, right? For example, like substrate, concentration, and different bacteria, and also the mediators and color signal. And he spent 1 month, and he got the model done. And then I tested his model and using my model and verified that his model is correct, right? And well, so the student actually, his performance is much better than I expected. So I then wanted to further challenging the student. So I introduced the feedback loop, right? Negative feedback loop to the student, and also the PID controller. Well, as you know, it's too challenging to introduce Laplace transform, right, to the high school student. So I did not do that, right? But I introduced the physical meaning of each term in the PID controller, and then I showed the student how to build a PID controller in the Simulink, and then the student can play around with the KP and KI and KD so that he understood how PID work and how each term affects the PID controller's performance. Right. So anyway, he spent another week, and then he built a PID controller, and then right here are some results and from his project, and so he got the simulation result for different KC value and KI value. And the project is pretty successful, and the student actually, he gave a presentation in the ASEE Mid-Atlantic Conference in 2015, and so his presentation is well reserved, and also he got an offer from Cornell University, but he ended with the University of Pittsburgh because you picked and offer him scholarship. Anyway, he picked the STEM major. He picked the bioengineering major. I'm very happy with that. So now I want to move to the second project, and then I want to show you. Before that, I want to show you how I linked the first project to the second project. So as I mentioned, the student, high school student, did a great job in the summer of 2014, and I talked with him in person, and then he gave me some feedback. One suggestion he gave me is maybe I should recall the teaching modules, right? And then more high school students can watch and then to run Simulink. And so that's why yeah, this is one reason. Another reason is, as you may know, Villanova is known for teaching, and the faculty at Villanova has a great passion to use innovative teaching approach in classroom. So in the last few years, we have some faculty and testing the flipped classroom teaching modules in the courses at Villanova. And so I have some good colleagues, who did the experiment, with the flipped classroom teaching approach. So that's why I also, hey, maybe I could try the flipped classroom teaching approach in my class by process control. So this is the motivation. So now I want to show you the textbook I use. I use this the SAM textbook, and by Drs. Seberg and Egger and Millichen and Doyle. Well, the reason for me to pick this textbook, actually it was a good book, right? And actually my Ph.D. supervisor is Dr. Huang. Actually, he is the Ph.D. student of Dr. Egger, right? So that's why one reason I use this textbook, because we had kind of a academic tree here. Anyway, the student also like this textbook. Again, as John mentioned, and we already published the teaching module in a journal here. So this is the journal, and actually in this year. And so if you want to get the handout, and you also can get it from the website of Villanova, you could just Google my name, and then go to my group website, and then you go to the education category, and then you could find either supplemental document for 3 modules for each one. And then I also posted the videos onto YouTube here. Okay, so here is an overview of the teaching modules, and so we have 11 examples and 3 modules. So the first one is about solving ODE in Simulink, and actually I show students how to solve the CSTR model. I'll show you later, and that is a long example, so I break it into 3 videos. So again here, the individual videos typically last 15 to 20 minutes, and the reason for this is my colleagues at Villanova, they did a lot of experiment on the flipped classroom teaching approaches, and the data shows that the time between 15 and 20 minutes is the best. So that's why I try to make the videos and in this for this time duration. And so the second module is the Laplace transform and transfer function operation, and we have 8 examples, and then for each example we have 1 video, and the last one is more about closed loop system and also periodic control design. So we have 2 examples and 2 videos. So before I introduce these teaching modules to a student, I did finish the introduction of the modeling and control theory. So the student already know the control and modeling theory before they learn how to use MATLAB to solve the problem. Okay, so now I want to show you more detail about each teaching modules. First, I want to show you how to write the module to solve ODE in Simulink. So here is the CSTR model I introduced in the class. So I will. So for example, for the concentration ODE, and then so I show students how to break the ODE into different levels, right? For example, level 1 is the minus sign, and then after that, level 2, here is the product, right? And this product, and then another one, so that we could represent the ODE, right, in different levels, right? And actually, just like how can we break the ODE into different modules, and then we could use those modules that are available from Simulink and to build the model. So I show the students step by step in the video how to do that, and then most students can reproduce the result and just by watching the video. So this is module 1. Now I talk about the module 2, and so in module 2 is we try to translate the ODE model in the time domain into the Laplace domain, which we're going to get algebra equation look like this. And well, it's very challenging for students to do Laplace transform or also to solve inverse Laplace transform. Right, and I will show you an example later on this. And so after we get the transfer function and we also show what the output look like for different inputs, right? And also the AB value, right? The denominator of the transfer function also will influence the system's behavior. And so these are the example I show and for the Laplace transform and transfer function. So I want to show you a little bit more about the handout here. So in example
Jacky, I just had one question for you. Just as as you teach these students, how do they have prior MATLAB experience before this course, or is this the first time you're teaching them MATLAB?
Very good question. Actually, I should mention that in my motivation. Actually, the students at Villanova, and especially in chemical engineering, and they learn very little MATLAB, and in first 3 years, it's kind of they don't know MATLAB that much when they learn my course. Yeah, I forgot to mention this. Actually, let me show you. I have one slide for this I forgot to mention. And actually, we see here many universities actually, but not Villanova, have included MATLAB in their curricula. And we did a survey, in 2014 on this, and that's why I talked with the department head saying, hey, we should include the MATLAB and provide more MATLAB training to students.
Great.
Yeah.
Okay.
Yeah. Good. So see here. So the example 2, example 1 is more about ODE simulation, right? Example 2, see, I show how to solve the inverse Laplace transform. Right? The student, they are struggling to solve inverse Laplace transform by hand, right? And after they learn how to do that using MATLAB, they were very happy. And I also showed the student how to do the Laplace transform for very complicated input signal, and then so in this approach we just type the code in the command window, and then I show the student another approach. Right? I show student how to, instead of solving the Laplace transform, we represent the model in the transfer function, and we represent the input signal in Simulink, so that we don't need to do the Laplace transform of this input signal. So that's another approach. So how to get the output without solving the inverted Laplace transform in Simulink. So the example, now I want to show you example 5, and I show students how to create a complicated input signal from the signal creator provided by signal builder from Simulink. So the student can build, for example, triangle, and pulse, or all type of complicated signal here, and without solving the Laplace transform. Right, and then in example 6, I show the student, for the second order system here, how the value of zeta, the damping coefficient, will change the output profiles, because the second order underdamped system, we see the oscillation in the step response. And in example 7, I show the leadless system, how the time constant in the numerator change the output profiles. So here we have lead system and we have lat system. And in example 8, I show the concept of inverse response, so I use the summation of 2 parallel first order systems to illustrate the inverse response. So for example, the K1 and K2, they should have different size. One is positive and another is negative. And tau 1 and tau 2, they should have quite different values. So the student, they play around with the K1, K2, and tau 1 and tau 2, and so that they had a better understanding of the inverse response. And in example 9, and I show the student how to simplify a model. For example, the model had more had higher order system. For example, the model had more than 2 terms as term in the denominator. And I show student how to simplify it using 2 different approaches. Right, and so as you know, the Taylor series expansion. Another one is the Dexter half rule, and then we compare the simulation result from the original model and then also from the simplified models. So based on that, the student have a better understanding of the simplification. So this is the module 2, and then I'll show you the module 3. It's more about Ph.D. control design. So first I show the student the diagram, right, and then how to represent the control system in this diagram. And then after that, I show so example 10. I show, for example, if I just use the P controller, right, and then we get this closed loop transfer function, and we could get different output profiles for different KC values. So I want to show the student how the KC value will change the system's behavior, and we could see that if the KC is too large and the system is not stable, so the student have a better understanding of the influence of the KC, the controller on the system behavior. And then I also show the comparison of different PID controller and if we use P and PI and PID, and also student also try different PID tuning method to decide different PID controller. Right? So this is module 3. Okay, now I will show you how I implemented the flipped classroom teaching approach. So the video was sent to the student 1 week ahead. Then at the beginning of the class, and the student will do a quiz. So I just want to make sure that the student watch the video. The quiz is quite simple. If the student watch the video, and then they should get a quiz done. And after that, I provide about 10 minutes question and answer section, and if the student have questions. So after that, the student they were required to reproduce the MATLAB programs in classroom, and then after that, I provide another lecture, another class time for the student to do the homework. And after the student finish the assignment, and then and they will they did a anonymous survey. And so now I will show you the questionnaires of the survey, and also the survey result. And the survey has 3 sections. In the first section, we try to evaluate students' improvement in the technical skills. And in the second section, we want to get some feedback from the student on the inverted classroom teaching approach. And in the last section, it's more about open-ended questions. Hey, what the student like or dislike the flipped classroom teaching approach. So now I'll show you the session 1, right? This question here. So we have 4 questions. Question 1 and 2, and are used to evaluate students' improvement in solving ODE simulation, right? And in doing Laplace transform, right? Or also handling the transfer function, and in PID control design. So this one is only for the ODE simulation, right? For the PID controller design, or also the Laplace transform, we just change the technical skills to accordingly. So as we could see, well, although the student had learned those technical theory, right, in classroom, and MATLAB did enforce the students to learn more, right? And then to also to improve their understanding of those theory. So in problem 3 and 4, and we want to evaluate students' math skill to solve ODE, right, and also Laplace transform, and then the PID control design. And so again, right, as I mentioned before, right, the students they did not learn MATLAB that much before they took my course. So therefore, you can see, so before they took the 3 teaching modules, right, the MATLAB skill is low. Actually, you can see the MATLAB skill is increasing in question 3, right? From module 1 to 2 and 3 because they learn more and more MATLAB, right? And then yeah, so after they learn, after they took the teaching module, right, and did the MATLAB assignment, and they are quite confident with the MATLAB skills here. So this is session 1 about teaching survey. Now let's talk about the students' evaluation of the flipped classroom teaching approach. So 1 means totally disagree, and 5 means strongly disagree. Strongly agree. The first question is, the inverted classroom format improves students' overall learning, and you can see for all 3 teaching modules, and the score the students scores from 3 to 5, and it's quite positive. So the second one is the flipped classroom format require more time, right, to do the work. And actually, the students they did things that they spend more time in the flipped classroom teaching format. And number 3 is the flipped classroom approach improves the student understanding of the principle and theory. Right? So again, you can see from this question 3, right, for all 3 modules, and the students and do these things that the MATLAB experience can help them to learn to understand more the concept. And question 4 is the flipped classroom approach improves students' ability to solve problems. So you can see after question 4 here, right, and the student become more confident to solve problems. And so I talked with some students. They told me that they feel confident because some of them actually they didn't know how to solve the problem by hand, but they do know how to solve problem by MATLAB. So they like MATLAB, and after they finish all the training, at the beginning they quite resisted the MATLAB, right, because they learned little MATLAB before they took my course. And problem 5, and the student receive more personal attention in the flipped classroom approach, right? The score also is positive. And last one is the student will recommend more. I will recommend the flipped classroom approach to other courses. So actually, they did recommend this teaching approach to other courses. Well, here's lesson 3. It's open-ended questions. Again, well, we can make everyone happy, right? And some students they like it, like this teaching approach, but some they don't. So here's some right aspects they like. They like the flipped classroom approach because they could watch the video anytime, anywhere, right? And also they could ask the instructor the questions when they do the homework. Also, the MATLAB module help them to learn the materials. Well, the aspect of the student they don't like the flipped classroom teaching approach is several students mentioned that they spend much more time in the flipped classroom teaching approach because they have to watch the video. Right, they have to like watch the video before the class, and at the same time they also have to attend the class. So it seems that they have more time to stay with the instructor. So and also the student, actually one student mentions that it's very challenging for him to take more than 2 flipped classroom courses at the same time. Right? Also, some students complain that they got attracted by other things when they watch their videos. Like because the instructor is not stay with the student, they could do whatever they want. Anyway, this summary of the project 2. So we developed a flipped classroom teaching approach, and the survey shows that the students they were quite positive with the flipped classroom approach, and also and the students' skills of using MATLAB have been significantly improved. Now, so I shortly introduced the last project. Yeah, hopefully. So it's about web-based teaching approach to educate high school student MATLAB in modeling microbial cell. As I mentioned before, this is an extension to the project 1, and we just change everything to the web-based format. Actually, web-based format and is not pure flipped classroom teaching format, but they are similar. So that's why I say it's still regard this as a flipped classroom approach. So here again, this is the motivation, and I want to get more students attracted by this project, and to train more students at the same time, and also provide flexibility to the student. Right, that's why I recorded the teaching modules. So here I only have 3 videos in this project. And the first one is I show the ODE, right? Because some students they don't know what ODE is, and then I show students how to develop the ODE model in Simulink for this water tank example. And this is a very simple example, and then the students we feel more confident. And after that, I show the students step by step how to develop the ODE model for the CSTR model I showed you before. Right, that's a more complicated one. So after a student finish this complicated CSTR model, and then I introduce the background of microbial cell, also the ODE model of the microbial cell, and then the student begins to do the project. And this is how I implemented the web-based teaching approach. And actually, the student only worked for 4 weeks on this project. So in the first week, the student watched the first 2 MATLAB training videos, right? And one for the water tank, another for the CSTR model. And then the student reproduced these 2 examples, just step by step, right? And then send me their result and on a Friday, and then I organize a Skype meeting with each student, and then in week 2, the student going to watch the introduction of microbial cell ODE model, and after that the student just work on the microbial cell ODE model project. And on each Friday, right, from weeks 2 and to 4, I organize a Skype meeting with the student. I also use the TeamViewer. In the TeamViewer, I could help students to debug their programs, to help them to fix their programs. And then in most students, and they were able to finish the project, and by the end of the week 4, and then in week 5, they're going to submit it. They submit a report, and then and I also asked them to do an anonymous teaching survey. Well, you might ask me how much time they spend in each week. Actually, I did not check their time, right? But I did do the survey and how much time they spend in each week, and typically they spend 4 to 8 hours per week, and depends on the student's ability. And for the teaching survey, I try to make it anonymous, right? So what I did is I asked the student send their surveys to my wife's email, and then my wife printed the survey and then handed the survey to me, so that I didn't know who did the survey. Okay, so here again similarly, right? We have we organized a survey, and in this section, in the first section is more about the technical, right? First of all, how the MATLAB skill improved. So 1 and 2, again, all students, they did not learn MATLAB before they took the project and joined the project. So you can see the MATLAB skills have been improved. Right, and then also, actually, it's 3 to 2, 3 to 4 is MATLAB skill, and 1 and 2 is how their ability to solve ODE. So the high school students, they don't know how to solve ODE before they did the project, and after that they know how to solve ODE. So 1 and 2 is about ODE solving, and 3 and 4 is MATLAB skills, and then 5 and 6 is their knowledge of microbial cell. And you can see that after they did the project, their skills have been improved. And then section 2 is how they do is more about the web-based teaching approach. And the first one is the web-based approach can effectively convey the knowledge of MATLAB and MFC. The second one is the videos are clear and easy to follow. And number 3 is the Sky meeting and can help students to answer the questions. Number 4 is the project is too challenging to a high school student. So most students, they say the problem and the project is not that much challenging. This is out of my expectation, actually, to be honest. The project should be challenging. But anyway, and the number 5 is the student will recommend this project to their classmates. Number 6 is the microbial cell project, and very interesting and help them to stay in this project. Right? And the number 7 is the student this project helps students to stay in the STEM field. Right? Actually, all the students, they pick the STEM field major after they finish the project. So here is just a brief overview, instruction of the question 3, right? That's the result of question 3, what they do like and don't like, the web-based approach. Similarly, they like the web-based approach because it provides the flexibility to the student. What they don't like is they can't ask the question right away, and then the Simulink, especially sometimes if the model is complicated, there's so many lines in Simulink, it's very difficult for the student to find what's wrong in their model, right? Here's summary. So we develop a web-based teaching approach to educate high school students, and then all students finished the project and they did good job, and right, they got offer from top school like Cornell, UCLA, and University of Michigan, right? And all of them stay in the STEM major. So in the future, we will invite more local high school students and to participate in this project. So here's I appreciate my the help from my collaborators and at Villanova, and also my students. They're great students. And I also appreciate the financial support from Villanova, and especially the VITAL, right? The teaching VITAL the Villanova Institute for Teaching and Learning. Thank you for attention. Any questions, welcome. And again, if you can ask me questions, and on the webinar, you can send me email, or you could also visit my website, and all the handouts and videos are there. Thank you.
Fantastic. Well, thank you for that presentation, Jacky. Excellent. Not only experience, but you showed quantifiable results on how they've, their reaction to the class. I just had one question on. You mentioned something very interesting, which was that in general, students are looking to try to get more information more quickly. You mentioned that some of the students said it took longer for them with some of the flipped classroom approaches. Do you think that's a problem? Do you think, I mean, they obviously are learning a lot more that way. What are some ways that we could potentially make it more time efficient with the flipped classroom?
Well, very good question. So the students, they thought they spend more time because they have to spend the same, like they have to spend the same time with the instructor. For example, they had to come to the classroom to do the homework, and also they had to watch the video, and that's why they think and they spend more time. Another one is they got distracted. For example, they watch the video like in the morning, and then they don't may come just knock the door and hey, that's a funny right video. Let's watch together, right? And then the student they watch the video, like the fancy video, and then funny video, right? And then come back, and then they have to watch the video again because sometimes he just forgot, all right. So some students just complaining about this, and they got distracted. So one way to improve the efficiency, maybe maybe we pair the students in groups, and then they watch the videos together. Like for example, 5 to 6 students as a group, they had to find a place and then watch the video together, and so that they don't get that much distracted. Stuff. Yeah, I think the distraction is the issue. And to be honest, well, I talked with some students. They did things that the total time is similar. So if they add the time, right, of watching the video and doing the homework together, actually similar to the traditional teaching approach. But some of them just get distracted, and then they had to watch the video, and then they forgot, and they watch it again. Because in my example, and for example, the CSTR model is pretty complicated. If you miss one step, you can't get the right results.
Fantastic. Well, great presentation. Any other questions from the audience? Okay, we'll go ahead and contact you. We'll go ahead and contact you with any other questions at your email below. Thank you for including that. And thank you for the very engaging and interesting presentation about your experience with the flipped classroom, and especially with teaching MATLAB and Simulink. It's very admirable that you were able to do this with high school students as well. I really like how you broke down the functions in Simulink, not just like an S function or an M script that you embed, but you break down the individual elementary operations, something that a high school student could be able to tackle. So thanks for sharing some of that. Very interesting, especially for those of us who teach process control, and we're trying to look for new ideas. Very interesting and informative in how you presented today. So thank you.
Thank you very much. Yeah.
Okay, well, with that, we'll go ahead and conclude this webinar, and we'll go ahead and post it on YouTube afterwards. So thank you again.
Bye-bye.